Welcome to Physics Can Be Fun with me, Stephen Thomas. Today we're asking the question, how much work does a science teacher do? What I have here is a scale and a table, and I've been doing push-ups on the scale. And I'm trying to figure out how much work have I done. So let's get started. When I weighed myself on the scale, I found that my weight was, on the scale, that's not my full weight, 150 pounds. But we don't, in the SI units, work in pounds, we work in kilograms. And here is a conversion. 1 pound is equal to 0.454 kilograms. So let's convert 150 times 0.454 times 0.454 equals 68,1 kilograms. So that is what I have been doing press-ups. And let's measure the length of my arm to find out how far exactly I've been pushing. So there would be about 0.4 of a meter. So I'd say I've been pushing about that far, 0.4 of a meter. So the height that I pushed was equal to 0.4 meters. So let's ask ourselves, how much work did I do in one push-up? Well, we have a formula for work. Work, capital W, equals force times displacement, delta X, where force is also equal to the force of gravity, which is otherwise known as my weight. And weight depends on two things. It depends on my mass and it depends on gravity. So weight is equal to mg. And the mass in question here is equal to 68,1. 68,1, not 4. Times g, which is 9,8. And so what is the weight in newtons going to be? It's 68 kilograms times 9,8 times 9,8 equals my weight. Now we're not used to expressing weight in newtons, but it's actually equal to 667 newtons. So that's equal to 667 newtons down. So there is the force downwards that I actually was exerting on the scale. 667 newtons. Now, let's go back to this formula. Work done is equal to force times displacement. So, work is equal to force times displacement, which is going to be equal to 667 times my displacement was 0,4 meters. That was the length of my push-up. Times 0.4 of a meter equals, I did 267 joules. 267 joules of work. It does not have a direction, being a scalar quantity. It was 266,95, but I'm rounding that off to 267 joules of work in doing one press-up. So 267 joules, and let's say I did my press-up in 1 second. That's quite impressive. If we wanted to work out my power, we could go further on. Power is equal to work done over time. So the work that I did was 267 joules over the time. Let's say I did it in 1 second. So my power was 267 watts. And that is my power output while I am doing press-ups. So I'm about 2.5 of those incandescent 100-watt light bulbs. That was my power. So should we see if we can be more powerful maybe in standing up on this bench that I'm sitting on? Let's stand up onto the bench in 1 second and let's see how much work I do. And 1. So, standing up on a bench, how much work did I do? Well, let's try and work it out in this little bit of space that we've got there. So, I don't have to repeat my formula. My formula is going to be work done equals force times displacement, delta x. What is my force? Well, we need to know how much I weigh because I take my total weight. So let me weigh myself. And I weigh 218 pounds. So let's write it there, 218 pounds. Let's convert it to kilograms times 0.454. Times, that's now my mass times gravity, which is times 9,8, times the distance which I stood up. Let's measure this distance, and the distance is 0.47 meters times 0.47 meters. Maybe it looks a little bit complicated, but basically all I'm doing is I'm taking my mass, converting it to kilograms, times G times H. Work done equals weight times height. And so that comes to 218 times 0.454 times 9,8 times 0.47 equals, I did 455,9 joules. I'm going to round it off to 456 joules. 456 joules of work. Now do you see that my legs are almost doubly powerful to my arms? And I did it also in 1 second. So if I divide this amount of work by time, my power, which is equal to work over time, is equal to 456 over 1, which is 456 watts. So my power output in standing on this bench was 456 watts. So that was about 4.5 of those 100-watt incandescent light bulbs. Now, granted, I only did it for 1 second. I probably couldn't keep that power output going for more than half a minute. So there we go. We've worked out how much work does a science teacher do. A science teacher can do 456 joules of work. What is his power? His power for 1 second can be equal to 456 watts, which is about twice as much work as his arms can do.